Have you ever wondered how digital systems count or store data? This question might seem simple, but the answer is a fascinating journey into the world of digital electronics. This realm is governed by two key players, counters and registers. They are the unsung heroes behind the scenes, making our digital world run smoothly. Let's first get a grasp of what we mean by counting and storing data in digital systems. When we speak of counting, we're referring to the ability of a system to generate a sequence of binary numbers in a predetermined order. It's like counting apples in a basket, but in this case, we're dealing with zeros and ones. And when we talk about storing, we mean holding on to these binary numbers for future use. It's akin to putting those counted apples into storage, except here, we're storing binary data. Now, where do counters and registers come into play? Well, counters are the digital circuits that do the counting. They generate a sequence of binary numbers in an orderly fashion. They're like the hands on a clock, ticking away and keeping track of time. But instead of hours and minutes, they deal with binary numbers. Registers, on the other hand, are the storage units. They hold on to the binary data until it's needed for processing or transfer. Think of them as digital cupboards, storing your binary apples until you need to make a digital apple pie. Together, counters and registers form the backbone of digital systems, enabling them to perform a myriad of tasks. From running your digital watch to powering complex computer systems, these digital circuits are at the heart of it all. But how exactly do they work? What makes them tick? And what distinguishes one from the other? These are the questions we'll be exploring as we delve deeper into the fascinating world of digital data. So buckle up, and let's embark on this digital adventure. Let's start by understanding what counters are in the digital world. Opening, counters, as their name suggests, are all about counting. Counters are the beating heart of digital systems. These digital circuits create a sequence of binary numbers in a particular order, like a metronome ticking away in the background. There are different types of counters, each with its unique characteristics. First off, we have the ripple counter. Picture a stone skipping across a pond, each skip causing a ripple. Similarly, in a ripple counter, each flip-flop toggles in response to the output of the previous one, creating a sequential count that ripples through the system. Next, we have the synchronous counter. Unlike the ripple counter, all flip-flops in a synchronous counter change states simultaneously. It's like having a group of synchronized swimmers, all moving together with the beat of a common clock signal. This makes synchronous counters faster and more reliable than their ripple counterparts. Then there's the up-down counter. As the name suggests, an up counter increments the count, while a down counter decrements it. Imagine an elevator going up and down in a building. That's your up-down counter, capable of counting in both directions. Lastly, let's talk about the modulus counter. This counter counts up to a certain value or modulus before resetting. Think of it as a runner on a track, completing a lap and then starting over. Modulus counters are often used to divide the clock frequency. Now, where do we use these counters? They're essential in a wide variety of applications. From dividing frequencies and counting events to running digital clocks and controlling sequential systems, counters are instrumental. They're the unsung heroes designing devices that require sequential or repetitive operations. So the next time you look at a digital clock or use a device that operates in a sequence, remember the humble counter. It's silently counting away, making sure everything runs as it should. Closing. Now that we've counted our way through counters, let's move on to registers. Registers are the digital equivalent of a safe storing valuable data securely. In the world of digital systems, a register is a crucial component that serves as a storage place for binary data. Think of it as a group of flip-flops, with each flip-flop keeping one bit of data secure. This setup allows registers to keep track of a series of binary digits, or bits, which forms the basis of information in digital systems. Now, there are different types of registers, each with its unique way of storing and retrieving data. Let's delve into this a bit deeper. First off, we have the parallel in parallel out, or PIPO register. As the name suggests, all bits in a PIPO register are loaded in parallel and can be read out in the same way. It's like a straight highway with data going in and coming out simultaneously. Next, we have the serial in serial out, or SISO register. In this case, data is shifted in and out one bit at a time, like a traffic jam where cars move one after the other. This method is particularly useful for data transfer in serial communication. The third type is the parallel in serial out, or PISO register. Here, data is loaded all at once, but is shifted out one bit at a time. Imagine a group of runners starting a race together, but finishing one by one. This method is beneficial for converting parallel data to serial data. Finally, we have the serial in parallel out, or SIPO register. In this type, data is loaded bit by bit but is read out all at once. It's like a one-man relay race where the runner passes the baton to himself, but all the batons are collected at once at the finish line. This method is useful for converting serial data to parallel data. Registers play a crucial role in digital systems. They are used for temporary storage of data during processing. They are fundamental components of computer memory, holding data for processing and transfer. Moreover, they are also used in arithmetic and logic operations within a processor. Having stored away some knowledge about registers, let's now compare counters and registers. So, counters and registers, two different entities with unique roles in the digital world. Starting with their functions, counters, as the name suggests, count. They generate a sequence of binary numbers in a specific order based on a clock signal. On the other hand, registers are the storage units of the digital world, storing binary data for temporary or long-term use. Moving on to data movement, counters increment or decrement their count based on clock pulses. They are like the ticking hands of a clock, moving forward with each tick. Registers, however, are more versatile. They can shift data in various ways, parallel or serial, or load data in parallel. They're like the drawers of a cabinet, able to store and retrieve items in different ways. But what about their applications? Well, counters are often used in applications that involve counting, timing, or sequencing. Think digital clocks or event counters. Registers, on the other hand, are the silent heroes of data storage, transfer, and processing in digital systems. They're the backbone of computer memory, holding data for processing and transfer. Registers also play a pivotal role in arithmetic and logic operations within a processor. Lastly, let's consider timing. Counters are closely associated with timing, and their operation is synchronized with a clock signal. They're the strict timekeepers of the digital world. Registers, in contrast, may not be strictly tied to clock cycles, and data movement can be controlled independently. They're like the free spirits, moving at their own pace. So, in essence, counters and registers are like the yin and yang of digital systems. Counters are the ticking clocks, keeping pace with the rhythm of the digital world. Registers are the versatile storage units, holding and moving data as needed. Together, they enable the smooth operation of our digital devices. With a better understanding of counters and registers, we can appreciate the intricate workings of digital systems. We've journeyed through the fascinating world of digital systems, counting and storing data. Through our exploration, we've discovered the intriguing characteristics and applications of two essential digital circuits: counters and registers. We've learned that counters are digital circuits that generate a sequence of binary numbers in a specific order. They come in different types, such as ripple counters that toggle in response to the previous flip-flop's output, and synchronous counters that change states simultaneously in response to a common clock signal. Then we have up-down counters that can count in both directions, and modulus counters that count up to a certain value before resetting. Counters, we've found, are indispensable in tasks like frequency division, event counting, digital clocks, and sequential control systems. They are the backbone of devices that require sequential or repetitive operations. Then we delved into registers, another type of digital circuit, but these are designed for storing binary data. Each register consists of a group of flip-flops, with each one holding a bit of data. We've seen registers in various forms like the parallel in parallel out register, the serial in serial out register, the parallel in serial out register, and the serial in parallel out register, each with its unique way of loading and reading data. Registers are fundamental to temporary data storage during processing. They are the building blocks of computer memory, aiding in data transfer and processing. They also play a significant role in arithmetic and logic operations within a processor. Finally, we compared counters and registers. While both are vital components of digital systems, they serve different functions. Counters generate binary sequences based on a clock signal, while registers store binary data. Their data movement differs as well. Counters increment or decrement their count based on clock pulses, while registers shift or load data in parallel or serially. In essence, counters and registers are the unsung heroes of our digital world, silently working behind the scenes to ensure our devices function smoothly. Next time you use a digital device, remember the crucial roles of counters and registers. Until then, keep counting and storing those bits.